Welcome back. So in last lecture, I talked about alkane and what will happen if we take one hydrogen from them. So alkane, we said we are dealing with a saturated compound that we have a carbon-carbon bond, and the carbon-carbon bond is a single bond. And in order to name it, we need to know the longest chain. And whenever we figure the longest chain, we will go after substituent and where they are standing, on which carbon they are located. Okay, we said if we take an alkane and remove hydrogen from it, one hydrogen atom from it, we will get alkyl. And YL is technically telling you that this group is attached to something. And I started with methane and ended with hexane. And as you see, like if we take one hydrogen atom from the alkane, you start with hexane and you will end it with hexyl. You want to say that I have 6 carbons attached to something. And if I want to put them like close to each other in one table, this is going to be technically the table that you need to know it. So you start with alkane and you take one hydrogen from it. If you take one hydrogen from it, you will get alkyl. And what's going to be the name for it? Take the ANE, take ANE from the system, take it out and replace it by YL. So METH represent like a number of carbons, or the methyl, it says that we have one carbon, and YL replaced technically the ANE. So ANE is gone, and we replace it by YL to get alkyl. Okay, and some of them I put a star, and I said keep this one in your mind that we might have more than one structure, and we will go after them very soon. Okay, so first thing, we said, let's go after the longest chain because that's going to be the parent. Next, we need to know the substituent, and all the substituent will be attached to the parent. So, and whenever you figure the substituent to the end of name of the substituent, you will add YL to say they are attached to the parents. So, for example, in this case, I have a parent. Okay, my parent is made of 3 carbons, 4 or 5 carbons, and the compound is cyclic. How do I name it? So simply, I'm going to say how many carbons I'm dealing with. The first one, I have 3 carbons. Next one, I have 4, and this one, 5 carbons. So the first one says I have 3 carbons. Because I have 3 carbons, I should say propane. Okay, propane. And I'm using different colors on purpose. Okay, pro means 3 carbons, AN means saturated, E means hydrocarbon. Okay, now this one is different than CH3, CH2, CH3. This is a propane. Okay, that's the correct name or the correct structure for propane. This is the top one is cyclic. So the way I'm going to fix the name, I will add cyclo in the front of the name, and that's going to fix everything for me. So anytime you have a ring, just simply use cyclo. Next one, I have 4 carbons, so I'm going to say this is technically butane. So I go butane. Okay, butane. So I go, or let me stick with the same color that I used for the previous one, butane, and I want to say this is cyclic, so it will be cyclobutane. And the last one, it will be cyclo. I have 5 carbons, so I'm going to say pentane. Okay, because I have 5 carbons there. Okay, so if your chain, or like if the parent happen to be open chain, it's not cyclic, just simply call number of carbon atoms and name it. And if it's cyclic, you will use cyclo in the front of the name, and that's going to fix the problem. Okay, next. Okay, so after figuring what's going to be the chain, okay, now that you figure whether you are dealing with cyclic or not, okay, you will go after the longest chain. Okay, figure the longest chain. What's the longest chain? This is the longest chain. Okay, that's going to be my longest chain. Okay, let me use different color for it. That's my longest chain. Okay, the longest chain has, let's see, I'm going to start from, let's see, say, okay, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So I have, I have 10 carbons. Okay, I have 10 carbons there. Okay, and this is going to be my longest chain. And now I have 3 substituents attached to it. Okay, let's go after those substituents. Okay, and substituent. Okay, so one of them, okay, is made of 1 carbon, and this is equal to a carbon that attached to 3 hydrogens, and this carbon is attached to something else. Okay, so this piece is equal to CH3. Okay, is equal to CH3. What's the name for it? Name it will be methyl. Okay, methyl. You want to say I have a carbon, 1 carbon that attached to the main chain. Okay, next one. I have 2 carbons here. Okay, so I'm going to say I'm dealing with ethane, but 1 hydrogen is missing, so I'm going to call it ethyl, and this is going to be equal to CH 2 times, then we have CH3. And that piece we call it ethyl. So the ethyl, it will be C2H5. And of course, this one is attached to something else. So forgive me. So you're going to write this. You're going to say, I have a carbon attached to something, C2H5. I have 2 carbons and 5 hydrogen, and they are attached to something. And how about the last one? Last one, you have 3 carbons. That one, you have 3 carbons there. Okay, so I'm going to say, I'm dealing with propyl. Okay, propyl. Okay, again, because I have 3 carbons, so this is going to be the formula for it. We have a carbon attached to another carbon, another carbon. Okay, so you have 3 carbons, and those carbons, they are supposed to be active except one of them. So terminal, you have 3 hydrogens there. Here we have 2 hydrogens, and that one has only 2 hydrogens and is attached to something. So this piece, okay, this piece, I'm going to call it, forgive me, that one I'm going to call it propyl. Okay, so we have methyl, ethyl, and propyl attached to the main chain, and this is our main chain. Okay, main chain that it, or the parent that it has 10 carbons. Okay, now does it matter whether we should start like labeling it from left or right? It depends where actually those substituents are. Okay, it's going to actually change the name. Okay, so it does matter. It does matter where you have the substituent. Okay, it's not going to be always correct to start labeling from the left or from the right side. You need to be careful about that one. Now, what will happen if I have a cyclic compound attached to, a chain? And then in this case, which one is going to be the parent? Okay, how do I figure which one of them is going to be the parent? Okay, let's bring an example. Okay, in this case, we have 2 groups attached to each other. One of them is an open chain. The second one is cyclic. Simply, from the where they are attached to each other. Okay, here from this area that they are attached to each other, try to count number of carbons on each side. Okay, so here I see 1, 2, 3 carbons there. Okay, how about the ring? 1, 2, 3, 4, 5, 6. Which one has more carbon? The cyclic one. So that's going to be the parent. This one, it will be the parent. And the parent has 6 carbon. So it's going to be, because it has 6 carbon, it will be hexane. Okay, hexane, because it has 6 carbon. And now, remember, this is cyclic, and because it's cyclic, you're going to say cyclohexane, because it's cyclic, okay? So we figured the name of the parent. This is the parent. Okay, how about the substituent, okay, or the branch that's attached to the parent? The branch has 3 carbons, okay? Because it has 3 carbons, I'm going to call it I'm supposed to say propane. Okay, I'm supposed to say propane, but remember, we are missing 1 hydrogen. Okay, and that hydrogen, we replace it with 1 carbon. You will erase the ANE, and you will add YL to the end of the name. So the correct name for the substituent, it will be propyl. Okay, so what's going to be the name for this compound? Okay, listen carefully. I want to say my propyl, okay, the propyl substituent is attached to the is attached to cyclohexane. So what I want to say, okay, propyl is attached to, to what? To cyclohexane. Okay, I want to say this. Okay, first you will figure the parent and the substituent, and I did it. Start with the substituent. The substituent is made of 3 carbon. You say prop, that means it has 3 carbon. Next, you want to say is attached to something. You want to say is attached to something. And the way you say is attached to something, you will add YL to it. Propyl is attached to what? To cyclohexane. Okay, and again, on purpose, I'm using different colors because I want to show you what's the meaning of each part. Okay, this one represents 3 carbons. YL means attached. Attached to where? To a ring that has 6 carbon, and that ring, it has single carbon bond. And what's the meaning of E? That's a hydrocarbon. Okay, that's a hydrocarbon. And this is the way we name it. Okay, another one. This is the place that they are attached to each other. So, okay, I went after these 2 carbon, I cut it from there, and now I'm going to count number of carbons on both sides. Okay, so I see 1, 2, 3, 4, and this one is 1, 2, 3. Okay, which one has more carbon? Clearly, the right side has more carbon. How many of them? 4 of them. So this is going to be the parent. Okay, the parent has 4 carbon. So you're going to say butane. Okay, butane. This is going to be the parent. How about the substituent? Substituent is made of 3 carbons and is cyclic. So cyclo, it will be technically the adjective. I want to say it's a ring, so I say cyclo. And I want to say I have 3 carbons. Cyclo, pro. Okay. So I have a ring made of 3 carbons. Next, I want to say that attached to butyl. Okay. In order to say attached to butyl, I'm going to add YL to it. So that's the name for the substituent. And in turn of this substituent is attached to butane. So after that one, I'm going to say butane. So it will be cyclopropyl is attached to butane. And that's going to be the correct name for it. Okay, again, last time, okay, I showed you this table. And I said some of those, okay, they have, like a star, okay, and I put a star on them. And the purpose for it, or the purpose behind those star is like you might have more than one structure, and you need to know those structure, because some of them they have a common names, and you have to get used to actually those common names. Okay, and so for example, if you have 4 carbons, those 4 carbons they can be attached like that, completely linear, or you can say I have 3 carbons attached to each other, and now I can draw it that way. Okay, these two, they have the same formulas. They have C4H, it will be 10. This one also, it has C4H10. Okay, what's the difference between them? The difference between them is the connectivity. Okay, what do I mean by connectivity? The way I arrange, those carbon atoms around each other. Okay, and I used to have only one carbon attached to, attached to the terminal carbons. Okay, and here I had 2 carbons there, and each carbon attached to 2 neighbors. Well, now I got new carbon. That new carbon is attached to 3 carbons, and I got 3 terminals carbon. So I arrange the connectivity. We say if you are dealing with the same formula, the only difference between them, the way you arrange them around each other, say you're dealing with isomers. If you can have isomer for alkane, okay, if you can have isomer for alkanes, then you can have some isomer for alkyl. Okay, because how do I get alkane? I subtract H from it, and that's going to give me alkyl. So if you have isomer for alkane, you will have isomer for alkyl. And you need to know the name for each one. Okay, thank you very much.